Look at the quadratic regression. So similar to linear regressions, now as you know, not all points will lie on a line, right? And or will follow a line trend. With the recent COVID-19 pandemic, for example, we see that the numbers are growing and they're growing exponentially, right? So they're not following a linear trend line. So these are things that we always collect, we always look at, we always graph, because the graph will give us a much better explanation of or a much better, if you want, like looking at the future, right? Prediction, to predict what's going to happen. So that's why we want to graph, that's why we want to find the trend line, that's why I want to find the best of line, the line of best fit, or the equation of best fit, so we can predict what's happening later, or what might happen later. So not everything is linear, as I was saying. So a lot of time we have points that are lying on a quadratic graph, or points that are lying on a exponential graph. Now we're going to have to look at the points. As we seen in the previous activity, you can do your first difference and your second difference, and if your first difference is not constant, that means it's not linear. If your second difference is constant, that means it's quadratic, right? So this is how you know using your table of value. But also when you're looking at your graph, you're going to see it and you're going to figure out that's not linear, okay? So let's look at this example. The following table and graph show the mean distance from the sun and orbit length for the planets in our solar system. So we have the different planets, we have the mean distance from the sun and their orbit length. So let's see, we're going to have to graph this, and then we're going to have to predict what's happening, and see what kind of regression line we're going to use. So copy all of this and then paste it in Excel. All right. So we're going to copy and then we're going to paste in Excel. So I've already pasted this in Excel. And then we are going to graph. Similar to what we've done before, we're going to highlight just the points, and then we're going to go to Insert, Scatter, and pick the first graph. So you see here, let me just make this bigger and close this. All right, so what do we see here? Let's see, can I make this a little bit? There you go. So we see that it's not linear. We see that there is the data here that they are clustered together and then they grow fast on the other side. All right, so we know by looking at this, we know it's not linear. So first of all, let's add the axis and let's add the chart title. So the axis, for my x-axis, I have the mean distance from sun in millions of kilometers. Okay, so that's important to note. So this is the mean. Mean means average distance from the sun, and then make sure you include millions of kilometer, because that's your unit. So when you see 500, that's actually 500 million kilometer. And then for the orbit length in days, we are going to change the title for the Y, and we're going to say orbit length, and then the unit is days. And then what are we going to call this graph? We're going to call it, let's go back to this, and then we're going to call it planetary orbit, or the solar system. Let's call it planetary orbit. As long as your title has something meaningful, and then when I read it, I know what I'm referring to, okay? All right, I don't need that series, so I can delete that. Oops, I deleted my whole graph. Thanks for the undo. I need to make sure that I'm just picking the series. You don't have to delete it actually, but I just like to, because I don't like clusters on my, doesn't want to, I guess. All right, now let's add a curve of best fit, or a graph of best fit. So press on one of the points, doesn't matter which one, right click, add trend line, and now you see that the linear is not a good fit. All right, so we're gonna pick polynomial. Polynomial means quadratic as long as it's an order 2. You see how better this fit is? So I'm gonna show you again, linear. Okay, let me move this a little bit. Oops. Undo again. Here we go. Linear and polynomial. Look at the fit, right? Much better as a polynomial. Make sure it's order 2. That means it's quadratic. Again, you're going to display equation on the graph, and then we're going to display the R squared, and you see it's 99.97%. That's great fit. So now I have this. If you guys want to copy this, and if you want to put it on Word document, because later if you're, let's say you're doing your assignment and you want to copy it and put it on your Word document, there's 2 options that you can do depending on what kind of computer you have or what kind of technology hardware you're using. If you're using something that's related to Apple or Mac, you can do Command Shift 4, and then that will give you a snipping tool. Okay, once you do this, it will snip, it will take a picture. If you're using anything other than that, you might be able to look for a tool called snipping. So if you search for snipping, it will appear, and then you can take a picture and then copy that picture into your Word document. Okay, so remember the word snipping. If I'm looking at the equation, my equation is quadratic, so it's to the power of 2. It's 0.0018x squared plus 5.6493x minus 577.7. Sometimes you probably want to, for example, that middle term, if it has too many decimal, you probably want to reduce it to 1 decimal and round. Okay. I hope this was helpful for you guys.